Greetings, chemistry students. This is Mr. Resentes. I'm on page 74. We're talking about periodic trends. This is chapter 5 of your book. Now, we want to briefly review some of the concepts of the periodic table, some of the patterns that we see. The vocabulary is very important to just keep repeating. These are periods, groups as you move across the table. And we said that this was the S block, we said this is the D block, and this is the P block. What that means is the elements within this region of the periodic table, within these groups and within these periods of the periodic table, have electrons in the P sublevel. These transition metals here occupy the D sublevel. And the elements over here in the alkali metals and the alkali earth metals have electrons in the S sublevel. Now, if you go down periods, the period 1, 2, 3, which are rows, that's the principal energy level. And elements in a group, these are groups from, these are groups, these are periods, my apologies, within a group have similar properties because valence electrons, because of valence electrons, outermost electrons, with similar configurations. All right, because they have a similar configuration, P, as I said, and the difference is the principal energy level. They all are going to have very similar properties. So all the elements within a certain group are going to have very similar properties. Okay. Now each group has one more valence electron than the previous. So each group, this has one valence electron, two valence electrons, 3, 4, 5, 6, etc. Right? So these predictable ways that properties change in the periodic table are these periodic trends. The periodic trends which I'm going to try to address. There's three principal periodic trends that I want to talk about. The first periodic trend is the atomic radii. And all we mean by that is the distance from nucleus to the edge of the cloud. From nucleus to the edge of the electron cloud. Alright, so here's the best configuration I can show you. Most of the element is electron cloud, so that would be the atomic radii. Now, the trend that we see in atomic radii, I need another periodic table. Here's my periodic table. The trend that we see in atomic radii is that the atomic radii gets smaller as you move across the groups. It gets smaller. And the atomic radii get bigger as you move down the periods. Right. Why? Well, the atomic radii decreases. It decreases along groups because more protons pull the electrons. toward the nucleus. As we move in this direction, remember this has 1, 2, 3, 4, 5, 6, more and more protons as we move that way, more and more positive charge. The more positive charge wants to pull the electrons in. Atomic radii increases along periods because additional electrons repel. Each other. Alright, and then whenever that happens, they spread out. Because they spread out because they're repelling one another. So as we go down, remember the principal energy levels are increasing. As the principal energy level increases, there's more and more electrons. As there's more and more electrons, they want to repel one another, and they get big. As we move from left, if we move from left to right, we have more and more protons. So the protons pull the electrons in closer together. The second trend. The second and third trend really has everything to do with formation of an ion, but the electron affinity is the amount of energy needed to release the amount of energy released, when an element gives up an electron. The amount of energy released when an element gives up an electron. All right, and here we find, here's my rough sketch, very rough, of a periodic table again, and here we find that it increases as we move across the groups, and we also find that if we move down, the electron affinity would it would decrease as we move down, because as we move down, then there's more and more electrons, so the amount of energy to give it up would be less because there's more and more electrons, and as we move across, there's a higher positive charge, so it takes more energy. It gives up more energy whenever it's released. So if we move across the periodic table, it's more positive to the right. It's more, and that's going to hold those electrons tighter and tighter and tighter. Trend number three, ionization energy. In trend number three, we have ionization energy, and that's the energy required to remove an electron. So as we saw before, the electron affinity was the amount of energy released when an electron is given up, and here it's the amount of energy required to remove an electron. So there's a slight difference. And remember, making an ion is ionization. And remember, an ion is just an element that's gained or lost electrons. So the greater the proton number, and those are positive, the greater the proton number, the more energy to remove an electron. So it takes more and more energy to pull that electron off because there's more and more positive. So that increases across the groups, as we said before, moving from left to right. And then it decreases it decreases, ionization energy does, as we move along the periods, because it takes less and less energy as we move through the periods, because there's more and more electrons as we go from the principal energy levels, and as there's more and more electrons, there's a repulsion force, and they push one another out, and so consequently it takes a lot less energy to lose one, because they're spread out because of the repulsion forces of the same charged negatively charged electron. So as we move across, the greater the proton is going to want them to stick to the nucleus. So to sum up, we have the electronegativity increases as we move, and the ionization energy increases as we move across. The atomic radii decreases as we move, or it increases as we move across. The opposite of this. The atomic radii decreases, so this would have the smallest atomic radii in this corner. We would have the biggest atomic radii in this corner, and then the electronegativity and the ionization energy follow the same pattern, and it decreases as you go down, and it increases as you go across.